Hello learners, I hope you are doing well. Welcome to our lesson today. It's Teacher Grace here. In today's lesson, we'll cover composition of an atom. What do I mean by composition of an atom? So when we are trying to represent an atom or an element in the periodic table, it is represented such that we have the elementary symbol, then the superscript, this one written on top here, that one, this one is the mass number, then the subscript is the atomic number. So by the end of today's lesson, number one, we should be in a position to differentiate between mass number and atomic number. We had mentioned them previously in some of our videos. If you can't remember them, kindly get back to the videos and listen to our explanation. So when you talk about what is an atom composed of, an atom is composed of the elementary symbol. How is it written or represented in the periodic table? The elementary symbol. What do I mean by elementary symbol or elemental symbol? Elemental symbol is the chemical symbol. For example, hydrogen, chemical symbol is H. Then sodium, chemical symbol is capital N, small a. Potassium, chemical symbol is K. So capital K, that is the elementary symbol. Then the mass number written as a superscript, and then at the base we have the atomic number. So we can also have an atom being written as elementary symbol like this. Then if the atom is charged, it changes from an atom to an ion. So the ion has the charge here, either a positive or a negative. Similar to the one written here, we can have the mass number and we have the charge here. Then a good example of how it should be represented is here. Our element has a chemical symbol of X. We can have nitrogen here with a chemical symbol of capital N, nitrogen. Then this A will represent the mass number of nitrogen, and this Z will represent the atomic number. We defined mass number and atomic number, and we said atomic number here, this is the number of protons in the nucleus of an atom, while mass number is the sum of protons and the neutrons in the nucleus of an atom, and this X represents any chemical symbol of any element. Then, for example, they have said atomic number, which is written as Z of an element, is the number of protons in the nucleus of an atom of an element. For example, carbon is atomic number 6, meaning that it has 6 protons. Phosphorus is atomic number 15, it has 15 protons. Gold is atomic number 79, meaning that how many protons are there? You can write in the comment section and then confirm if you have gotten it right. Thank you. Then when it comes to mass number is the sum. Let me use that word, sum. That is why we have a plus sign here. Sum of protons and the neutrons in the nucleus of an atom. The sum of protons and the neutrons in the nucleus of an atom. So an element C, for example carbon with a chemical symbol C, it has 6 protons and 6 neutrons. Meaning that it has a mass number of 12. Phosphorus the same, it has 15 protons and 15 neutrons. It has a mass number of 30. Then gold, it has an atomic number of 79 and it has 118 neutrons. So when you sum the two, you get its mass number. Kindly do it. And this one now explains that atomic number, which is the number of protons, is equal to the number of electrons, but not equal a must. It is not a must for it to be equal to the number of neutrons. Look at this case. It has 79 protons, but it has 118 neutrons. So we are right kindly. I hope you are writing the answers in the comment section so that you can get to work it out later. Then a practice exercise is here for us to practice whatever we have read today. So this is how the atom will be represented, or the element will be represented on the periodic table. So Br is the chemical symbol, or what they are calling elemental symbol. Then 80 is the mass number. 35 is the atomic number. So 35 is the number of protons, but 80 is the sum of protons and the neutrons in the nucleus of an atom of an element. So with 35 here, you asked about the number of protons, definitely it will be 35. The number of neutrons will say for us to get neutrons, we have to get protons plus neutrons to give us the mass number. Then you work out and get the following. Kindly remember that we said the number of electrons is equal to the number of protons, provided that the atom is not charged. Atomic number, number of protons. Mass number, 80. Atomic number, 35. Number of protons, 35. Number of electrons, 35. But number of neutrons is 45. Yes. So continue doing that practice, continue. You will see all those questions there where you should do practice. You go through the questions one by one, then you can do it. Looking at this one, in our first video, when we are talking about subatomic particles and atom, we talked about the ones that are positively charged. You can see they are in the nucleus. With others which do not have a charge, they are in the nucleus, and the negative ones. The same thing, we have positives, we have negatives, and then we have the negative ones. So 1, 2, 3, 4, 5. So we normally have 1, 2, 3, 4, 5. We normally have protons and neutrons in the nucleus, and 1, 2, 3, 4, 5. You see, the number of protons are 1, 2, 3, 4, 5. The number of electrons, 1, 2, 3, 4, 5. But the number of neutrons, 1, 2, 3, 4, 5, 6. Yeah, it's right. It is not a must for the number of neutrons to be equivalent to that of protons and electrons. So practice, you should write how many atoms, how many protons are there, how many neutrons, how many electrons. Then we come to the final quiz, subatomic practicals. Now here, you'll have to give me the charge, you give me the number of protons. Then if it is positively charged, it is a cation. If it is negatively charged, it is an anion. Then look at that one too. You do the questions and write them on the comment section. Give the answer. The number of protons is 66 because the atomic number is 66. The number of neutrons is 163 minus 66. You get the number of neutrons around 97 or 90, yeah. Then you get the number of protons.